This is Mars compared to Earth. Mars, you see it's a lot smaller. It's about half the size of Earth. Okay? It's a lot further out from the sun than the Earth is. I mean, it's the next planet out from us, but pretty far out there, so it's real cold. There's a couple of reasons why it's cold. It's further from the sun, so it gets less sunlight. But it also doesn't have much of an atmosphere. Mars has, its atmosphere is mostly carbon dioxide, CO2, which does trap some heat, but it's only about 1/100th, about 1% as thick. The atmosphere is not very thick. Could you shut the door for me, please? Alright. So there's just this thin atmosphere, it doesn't trap much heat. And why, does anyone have an idea why the atmosphere, I'll tell you what, 10 points. If you and your partner can guess, why the atmosphere of Mars would be thin? It's a good question. Why isn't it a real thick atmosphere like Venus has? There's something that makes it thin. Something you could probably guess.
You got it.
What did you say?
Why would Mars have such a thin atmosphere compared to Venus has such a thick atmosphere? Yes, Peach is correct.
Oh boy.
Anyone else?
We're coming.
Well, it's just a Mars one. Our Mars one.
Is that it?
Well, you can't get it.
Sure.
All right. Yeah.
Sure.
Yeah.
Let's go for it. Let's take a shot.
Yeah. Purple. Not right or wrong. Yeah, part of it right, part of it wrong, so I can't.
All right. Well, yeah.
Why? You know this. I want the reason why it's this.
All right, let's go.
Anyone else?
We're gonna try it.
Is that not right or wrong?
This isn't a reason.
My bad.
It's okay.
Saying the atmosphere is thinner. Why?
You want to be in this?
It's going to fall.
Sure.
Thank you.
Blue is incorrect.
Yeah, we did not do the same thing.
Orange is incorrect.
Is ours not white or wrong?
White or wrong?
Which one was yours?
White.
No, white is. Well, yeah, white is not right or wrong. You're just saying what I just said. Told you. Okay, so here's the reason. See how small Mars is? Got a lot less gravity. If you have a lot less gravity, you can't hold in a thick atmosphere. It all escapes into space. A bigger planet would have a thicker atmosphere. A smaller planet would have a thinner atmosphere. And if you get so small you're like our moon, you can't hold any atmosphere. So that's kind of what helps determine if a planet has an atmosphere. Its mass, its gravity. Gravity is the bigger you are, the more gravity you have. So that's interesting. So it's got a thin carbon dioxide atmosphere. Did you see the movie The Martian?
Yes.
You didn't see that? It's awesome. A guy goes to Mars with a group of astronauts, and they work on Mars, and he gets stranded there, and he has to figure out how to survive.
Is that like?
What was the guy's name? What was the actor?
Matt Damon.
Matt Damon.
What happened in that movie? Was that all scientifically?
Yeah, they had NASA scientists consulting with them on that movie.
So that could have happened.
Well, we haven't sent a person to Mars yet, but maybe in the future.
All he could grab was potatoes.
What's that? That's a great question, Santana. What's that white? That is like a polar ice cap. You know, like how we have polar ice caps. There is some water on Mars. It's mostly ice that's frozen in the soil. It's like permafrost. You know how we have permafrost in Canada and Siberia under the soil. There's ice. They have that there too, and so that that polar cap there's some water there, but it's mostly frozen carbon dioxide. If it gets cold enough, carbon dioxide in the atmosphere will freeze and land on the ground. We call that dry ice here. Have y'all seen dry ice before? That's a polar cap with mostly dry ice, frozen carbon dioxide, and some frozen water. So there is water on Mars. It's usually frozen as ice in the soil.
In the Martian, how did he get water? Like, did he?
He took rocket fuel that they had,
Right.
and he lit it and combusted the oxygen and the hydrogen with rocket fuel to make water.
And didn't he make it like condensation?
Yeah, it formed in the room and condensed. He put up a bunch of
Right.
plastic and it condensed on the plastic. It's pretty cool stuff. They made it where he had a bunch of rocket fuel that he could use. So yeah, you need to see that movie if you haven't seen it. I'll give you extra credit if you hadn't seen it. You can watch it. It's a good one. It shows you a lot about Mars. So what are some characteristics of Mars? Mars is tilted on its axis, just like Earth. Not quite exactly like Earth, but pretty close. Our tilt on our axis, do y'all know what our tilt is?
5.1.
23.5.
23.5 degrees. So Earth has a 23.5 degree tilt. It's not straight up and down in space, it's tilted. And Mars is a 25 degree tilt. So very close to ours. So Mars is like us in that respect. That means it would have seasons. That means as it goes around the sun, sometimes the northern hemisphere is toward the sun, that's the summer. And sometimes the northern hemisphere is away from the sun. If the sun were over here, that'd be winter. Mars would have seasons too. And you can see the polar ice caps on Mars grow and shrink with the seasons. There's also a northern one. You don't see it here. It does have seasons. And another thing about Mars that's cool, that's like it is here, Mars spins at about the same speed as Earth. Earth spins once around every 24 hours. Mars spins once around every 24 point something. 24 hours, 30, so about 24 and a half hour day for Mars. So if you were on Mars, the day would be like it is on Earth. The sun would come up and then the sun would set about every 24 hours, 24 and a half. So that would make it feel a little like home. Of course, it'd be freezing out there. It gets really cold on Mars, but not as cold as it does like on the moon in the shade. It's warmer than that because it does have some atmosphere to keep in some heat. But there we go. The average temperature is negative 63 Celsius, which is cold. That's way below freezing. So it will be real cold all the time. But the hottest places on Mars do get above freezing. So it wouldn't be like, people live below freezing on Earth, up in Alaska, and so they live all winter. It's below freezing, so you would have to wear a lot of clothes if you were on Mars, a spacesuit that could be heated, and you wouldn't freeze. Yeah.
Didn't the guy he dug up some kind of radioactive something?
Yeah.
What
They
was
had a nuclear something that they used. I think it was for fuel or something on their spaceship, and they had buried it there. And he dug that up and used it for heat. It was hot. It was warm all the time. Yeah. So Mars, if you look at the soil on Mars, it's all red, and that's because of the dirt has iron in it, and the oxygen that used to be in the atmosphere of Mars when Mars first formed, there was likely a lot of oxygen in its atmosphere. All of that reacted with the iron that was in the soil to turn it red. It's called iron oxide. It's rust. You'll see a rusty train track or something like that. That's because oxygen from the air has reacted with the iron in the train track to form rust. And so that's happened all over. There's no oxygen in the atmosphere. It's all sunk into the ground and reacted, and they have rusty soil. That's why Mars looks red. Yeah.
I heard that yesterday we tried to land a rover on Mars and they lost communication with it.
Oh, really?
Yeah.
Are you serious?
Yeah.
I didn't even know that. That was a NASA thing? Dang it.
Like the probe went down and it was about to land and then they lost complete communication.
Really?
Dang.
It's not easy landing something there. Have you ever seen pictures or movies where we have a spacecraft that goes out to the moon or goes around in orbit, and then when it comes back, it's like gets real hot and coming back, and you see fire and flames, and they have to shield the spacecraft? That's because the way we're slowing down that spacecraft is it's hitting the atmosphere. And it's like the wind is causing it to slow down. And if you're going fast enough, that creates a lot of heat. And orbiting spacecraft are going at about 14,000 miles an hour. So when they come back, they're really flying, going fast, and it creates huge amounts of heat to slow them down. Well, if you fire a spacecraft all the way to Mars, how are you going to slow that thing down? Mars has a thin atmosphere. So it does enter the atmosphere of Mars, and that slows it down some, but it has to have another way of slowing down. And usually they use big parachutes and things like that to try to slow the spacecraft down. But it's not easy. And so they've lost a lot of spacecrafts when they launch them trying to get to Mars and land the thing. I'll show you a cool video of what they do. What's that? To get to Mars? It's about it's about a year and a half voyage, and you got to understand that I guess I could do it better in a drawing here. So here's the sun. Here's the sun in the middle. And let's pretend Earth is right here. Let's use magnets here. Let's pretend this is Earth and this is Mars. You know, Earth goes around the sun and Mars goes around the sun. Now, because of Newton's laws, Earth orbits faster than Mars. The further you are from the sun, the slower you go. So, here's how they're kind of moving like this. And what you have to do is you have to launch when you're close. You see, if you tried to launch from the other side over here, you'd be way too far. It would take many, many years. And so what we do when we're going to launch to Mars, we wait until Earth's in the right spot, and then we send the spacecraft out. And it takes a long time, but you know, the spacecraft will get there. It's not exactly as I've drawn it here. But we call this, when they're close, we say that's a launch window. Have you ever heard them say that? That's a time at which you can launch because you're close enough. And if we ever send people to Mars, the spacecraft launches and the people are there, and the people could never come back until the Earth is back around in the right place to come back. You see what I'm saying? They can't ever make it back if the Earth is way over here. It's way too far away. And so we figure that if we launch to Mars, it takes a year to get there, and then they'll have to sit there for a year or so until the Earth comes back where we can get back to it. But it's not, you know, this Mars is moving too, so it's actually kind of, well, I'm doing it wrong. It's actually kind of like this. They're chasing one another around, you see. And there's a launch window. You see what I'm saying? And then we have to wait, we have to wait, we have to wait. There's another launch window. These launch windows come around about every couple of years. There's another launch window. Yes?
Oh yeah, in the movie, like when the people were going to study Mars,
Yeah.
were they prepared to stay there for a year?
Yeah.
So, like in that dramatic scene when they were leaving Mars,
Yeah.
that was after a year of being
Yeah.
there.
That's right. They didn't really talk about that much in the movie. They would have had to have been lucky that the accident that caused them to have to leave would have been during a launch window.
Yeah.
They didn't talk about that much in the movie. So they probably didn't want to get into it because people would be like, that would never happen. Yeah. The launch window is not a very long time. It's just probably a few weeks or months that the Earth and Mars are in the right place. Interesting. What is Mars like if you were walking around the surface of Mars? Well, it's got volcanoes. There aren't active volcanoes. There's no lava going on right now. There's nothing shooting out into space. These volcanoes all formed early when Mars was very young. You see, when all the planets formed from what we call gravitational accretion, all of these asteroids hitting one another and being pulled together by gravity, Mars was real hot then. It had a liquid center, just like the Earth does, and volcanoes going off everywhere. And then, since Mars is small, it cooled off, and all the internal heat was lost. And it still has a somewhat molten center, but it's very small compared to Earth's molten center. So there's not much of a magnetic field. Remember, the liquid metal in the center causes the magnetic field. And it's like most of its mantle, just our mantle has lava in it, but Mars's mantle is solid now. So there's no longer any volcanic activity. But there was a long time ago, so it's got huge volcanoes. This is the largest volcano in the solar system. It's not active. It's called Olympus Mons. And it's huge. It's the size of Texas. So this entire, if you put Texas right here, it would be about, fill this base right here. It's a giant mountain. It's way taller than Mount Everest. I don't know if they are writing here how tall it is. Why would it be so big and tall?
Because there's no gravity pulling down.
There's less gravity on Mars. There's less gravity. Yeah, you're right. There's less gravity, so these mountains can get real big. On Earth, there's so much gravity. Once mountains get big, they fall down. They're pulled down by gravity, so they only get so big. But Mars has less gravity, so its volcanoes can be way bigger. And so they've got some big ones there. Olympus Mons. There we go. 88,000 feet high.
Crazy.
Mount Everest is 30-something. That's the biggest one we have. So more than twice as tall as Mount Everest. Wouldn't that be fun to climb?
Yes.
It would take you months probably, since it's the size of Texas, in a spacesuit to get on top of that thing. But then you'd be like, I'm at the highest spot in the solar system.
Look on the smooth.
It looks smooth from a distance. It's probably not when you get up close. Yeah.
So is it not kind of like poking out of Mars like significantly when you're like looking at it, just like?
It does. As a matter of fact, that's a good question. Mars has these huge dust storms because the atmosphere gets churned up, the planet is spinning, and so you have movement of the atmosphere. And sometimes you get these dust storms. It pulls up a lot of dust that's on Mars' surface and it covers the planet. Well, scientists noticed from looking in telescopes at Mars that there was a spot, a big spot. Even though there were dust storms everywhere, there was a spot that rotated with the planet and didn't change. They didn't know what it was. It turns out it was the top of Olympus Mons, sticking above the dust storm.
Wow.
But yeah, that's exactly right. It's that big. But Mars will have almost these planet-wide dust storms where a lot of dust gets picked up and goes everywhere. They show that in the movie. They make it more intense in the movie than it actually is, but they still have a lot of dust everywhere. And our little rovers that crawl around, they have solar panels. We have several rovers that are on Mars going around right out, taking pictures, making samples, and their solar panels will get covered by this dust. And that'll cause them not to be able to get enough power, and some of them have gone out. And then so one of them went out because it couldn't get enough power, and then it just sat there for several months, or it might have even been years, and then another storm came up and blew the dust off. Sorry, I'm spitting. It blew the dust off, and it started working again. So the rover kind of came back. He finds one of those rovers in the movie The Martian. Y'all remember that?
Does he find the Mars?
He
rover?
digs one up.
Yeah,
He
like
digs
he
one of
builds
them
it
up.
or something.
Yeah.
Where do you want to watch the movie now?
It's so good. I want to watch it again.
Mars has this giant crack on it. It's called Valles Marineris. It's a big canyon is what it is. Has anyone here ever been to the Grand Canyon? It's this big, wide canyon that is way bigger than the canyon than the Grand Canyon. It's like a big crack. And let's see if we see it in this other picture here of Mars. I don't know. Whoa. I don't know if that's it. Can't tell from this picture. Sometimes if you look at a picture of Mars, it'll show this big crack in the front. And we're not sure why that is. We think maybe Mars was young, it was bigger, a little bit bigger, and then it cooled. And when things cool, they contract. And we think Mars may have cooled and contracted and formed this big crack when it contracted.
It's like the scarps.
Kind of like the scarps on Mercury. Yeah, very similar. Big crack right there. Mars' southern half of the planet sits higher up than the northern half. So if you had water on Mars, which we think it had oceans way in the past when it first formed, the whole northern half of the planet would be an ocean. And the whole southern half of the planet would be a continent, would be land. Because the southern half sits higher up than the northern half by a pretty good margin. And we're not sure why that is, but maybe when it cooled, it kind of went like that, and now you have the northern half lower, like the southern half like fit over the northern half. Maybe. They're not sure, they're still trying to figure that out. The Grand Canyon on Earth is 277 miles long. Valles Marineris is 2,500 miles long. 10 times as long as the Grand Canyon. It must be a beautiful sight if you could see it. It's a huge canyon. You could jump into it. And because Mars has a lot less gravity, you'd fall a lot slower.
Oh my god.
But you'd still speed up as Newton's laws of gravity as you're falling, and you'd end up because it's so much deeper, you'd end up hitting real hard.
Oh man.
You got your hopes up. Wait, so there was like a 10-foot drop or something, like a 20-foot
Yeah,
drop?
you go down
Really?
a lot slower than you would on Earth.
You'd still be going pretty fast.
Still be going pretty fast, but if it's only 10 feet, you could probably handle that.
How would you climb out?
You could probably.
How would you climb out?
Super jump.
You have to have.
Super jump.
You'd have to have one of those things on grappling.
That'd be the first thing I'd pack.
Fire extinguisher. Just jump up.
Yeah, you can shoot a fire extinguisher off. And
Oh my gosh.
hopefully they'd have actually the technology when we eventually get there. You'll have jetpack and you could use it because you have less mass, so you wouldn't have to have as big of a jetpack. There are craters on Mars. That's a crater on Mars. Now, since Mars does have an atmosphere, the craters erode a little bit. Just like we have erosion here on Earth. You can tell that's a crater, but it has eroded, and it's full of dust and dirt there that has blown in. So craters on Mars eventually fill up and get eroded, but they do last for a long time. And like I said, we think there's water on Mars. That shows one of the polar caps, and that's ice, water ice, and dry ice, frozen CO2. And that's the north polar cap. There's also a south polar cap. The north one gets bigger in the winter and gets smaller in the summer. And same with the south. It grows and gets smaller every year. We have found evidence that there's actually running water on Mars. See these 3 pictures? They were taken several months apart, but in the same year. And can you see the black streaks forming?
Yeah.
So what scientists think this is that Mars has some sort of internal heat. Even though it doesn't have volcanoes, it must have some lava or something underneath that's heating up the ice and causing it to melt and run down and make these streaks. And then when they came there the next year, the streaks were gone. So there must be something melting the ice that's under the soil. There's all kinds of channels and things you can see where there's been running water in the past. So there is some ice under the soil, and if we went there, we could use that ice to make water and to make rocket fuel. Because you can take water, H2O, and make it into hydrogen and oxygen if you give it enough energy, and then you can use that to fuel your rockets. So maybe we could land there, dig up some of the ice, make fuel out of it using solar power or nuclear power generators, and then take off from Mars in a rocket and go somewhere else. Go back to Earth or whatever. So like I say, there's a bunch of land. We've landed a whole bunch of things on Mars. This is a map showing we've got a rover called Opportunity there. We landed Pathfinder there. Viking was the first thing to land there, these Viking voyages. That was way back in the 1970s. There's a Phoenix lander here. There's another one called Curiosity, and I don't know where it landed, but it's still moving around. I think Curiosity is still going, and this Opportunity one is still going. And the one named Curiosity, I don't know where that is still going. And some of these things are big. This is what they look like. The most recent one is called Curiosity. It's the size of a car. And that flat thing there is the solar panel. And this thing right here has 2 cameras on it that are like eyes, so it can see. And it's got an antenna, and it sends back information to the Earth. And we can pick it up with our big radio antennas. And we have pictures coming from it. We have all kinds of data. The thing about these rovers is you can't just control them like you do a remote control car, because it takes like 4 hours. It's not that long. It's like 1 hour for the signal to get to Mars, even going at the speed of light. Mars is so far away from us that it takes a good while to get there. So you can't just tell it to turn left. It's not going to turn left for an hour later. So this thing has a computer on board that it decides on the movements by itself. And it'll only stop if it gets into a real predicament where it needs help from NASA. And it'll just have to stop and wait. And then the guy at NASA will program the way. But it's got like pre-programmed movements and experiments that it does.
So the closer it is to Earth,
it takes a lot less time if it's close to Earth. Yeah. You want to see how this thing got there? It's a beautiful, beautiful story. This is a neat video here.
Congratulations, fellow human beings.
Make you proud to be an American.
The network that became the internet and that. Boom! We've got brain-to-brain communication. Self-driving trucks.
This is the most expensive toy ever invented. Rovers in the top of that rocket.
move that fast in reality, all the things falling off. Wow.
Just passed 1 minute atmospheric entry current altitude 121 miles, current velocity 12,084 miles per hour.
We are now at an altitude of 73 miles, moving at a speed of 12,192 miles per hour. Expected parachute deploy in 5 seconds. 4, 3, 2, 1, mark. We're waiting confirmation the parachute has deployed. Parachute undetected. Traffic reporting that the still has the destination lander separation event has been detected. Traffic reporting lander is separated, moving at a speed of 173 miles per hour. We are near our terminal velocity. Expected retro rocket ignition on my mark. At this point in time, we should be on ground. Any signal that we receive from now indicates the vehicle would be alive, off the ground and bouncing. The spacecraft has to survive all the bounces for landing a success. No signal at the moment. Stand by. Signal strength is currently intermittent. We don't see a signal at the moment.
Looks expensive, doesn't it? That's what you get for $800 million. Which is actually pretty cheap compared to, say, an aircraft carrier, which is $100 billion. They could run 100 of those for one aircraft carrier. You think about the budgets people want to cut NASA here and there. Compared to our defense budget, it's really not that much. Mars has a couple of moons. The moons are really cool. I'll show you a video about the moons next time, but they're little tiny moons. What they are, they're captured asteroids. And this is a picture that the rover took of the two moons overhead. It turned the cameras up one night as the moons were passing overhead. And they're not that big. This is a little video that's in your book showing how Mars probably captured these asteroids. That's Jupiter. And here's little asteroids in the asteroid belt that got knocked by Jupiter's gravity. Watch it get knocked by Jupiter's gravity, captured by Mars. There you go. And now Mars has these two little moons. They're not very big. You can see they're not big enough to be round. They don't have enough gravity to round out the structure of them. And they're called Phobos. That's Phobos, and that's Deimos. Little moons that are going around Mars, and they're only that's 14 miles from one side to the other, and that's 8 miles. So that one right there is as big as St. Simon's, and that one right there is about twice as big as St. Simon's. So, if you drive to St. Simon's from the north end to the south end, it'd be like going across this thing.
There's no gravity on those at all?
There is gravity. Every object has gravity, but just not very much.
Yeah.
So,